Let's look at part C of the question. It reads, the pressure exerted on a swimmer below the water surface of density 1000 kilograms per meters cubed is 29,400 pascals. If G, which is acceleration due to gravity, is equal to 9.8 meters per second squared, find the depth of the water. We say the depth means height, and it is the one we are supposed to find here. So our H is under question mark. Under solution, we shall say H is under question mark. But we have been given the value of acceleration due to gravity here as 9.8. So our G is given as 9.8. When you are given G as 9.8, don't use 10. They can even give you 9.81. Use it the way you have been given. Don't change. Please use what you have been given. And if you are not been given at all, then take your G as 10. But in this question, we are given G as 9.8. The density of the liquid we are given is 1000 kilograms per, it is here, 1000 kilograms per meters cubed. That is density rho, which has this symbol. It looks like P, but it's not P. You should learn how to write this symbol. Then I said this symbol represents what? Density. Then P, which is the pressure, is given here. Anything in pascals or newtons per meter squared is actually pressure, 29,400. Now, using this, we all know that pressure in liquids, the formula is pressure is H, which is the height, times the density, times acceleration due to gravity. Now we substitute. So how many marks are here? There are 4. 1 is for the formula. Then for substituting, pressure as 29,400. The height is what we want, so you leave it the way it is as H, times the density is 1000, times acceleration due to gravity. This time it is not 10, but 9.8. When you multiply this side of the equal sign, you will get 9,200, not 9,800 H. So this side you have 29,400. Because you are interested in H, you divide both sides by 9,800. So these ones will cancel, you remain with the H. Then when you divide these two, you get 3. H is the height. The SI unit of distance is meters. So since we have here 4 marks, we have 1 for the formula, 1 for substitution, 1 for the correct answer for H, which is 3, and then 1 for the units, which is meters. Okay. Now, what are the characteristics of pressure in liquids? Characteristics of pressure in liquids. And the question now comes, state the characteristics of pressure in liquids. There are 3 main characteristics of pressure in liquids. The first one is pressure in liquids increases with depth. Depth is the same as the height. What does that mean? What does that mean? It means as the pressure increases, the height also increases. As the pressure increases, the height, as the height increases, rather the pressure increases. Then we also have another one. Pressure in liquids acts equally in all directions. Pressure in liquids acts equally in all directions. So there are 3 characteristics of pressure in liquids. 1, pressure in liquids increases with the depth. What does that mean? As the height of the liquid increases, pressure also increases. 2, pressure in liquids acts equally in all directions. Pressure in liquids acts equally in all directions at any point in a liquid. What does that mean? If you can get a small piece of a polythene bag, then you pour water, then you cover, you tighten the open end, and then after that you try to squeeze the water. Possibly you could make small holes on the polythene paper, then you squeeze the water. When you squeeze the water, you are exerting force and you are exerting pressure. What will you see? You are going to see the water spreading in all directions. So we are saying pressure in liquids acts equally in all directions at any point in a liquid. And then the third one is a liquid finds its own level. A liquid will always find its own level. So those are the three characteristics of pressure in liquids. So when somebody says, state the characteristics of pressure in liquids, the first one is pressure in liquids increases with what? Depth. Pressure in liquids acts equally in all directions at any point in a liquid. And lastly, a liquid finds its own level. I'm going to explain all these things and you will understand them very, very well. Now let's look at Hare's apparatus. Sometime back in primary, you might have heard about an animal called Mr. Hare. So today we are looking at Hare's apparatus. The name is attached to this apparatus. So today we want to look at what do you mean by Hare's apparatus. Now Hare's apparatus is exactly this diagram you are seeing. You see this diagram here. Now you realize that in Hare's apparatus, you have here two kind of containers, this one and this one. This one is holding a different liquid. This one is also holding a different liquids. Then you have two tubes. There is a tube here, there is another tube here. Both of them, they are connected here. So there is a tap somewhere down here. So in Hare's apparatus, we use Hare's apparatus to compare the densities of two different liquids. So here we shall have a different liquid. Here we shall also have a different liquid. We could call this one liquid A. This is liquid what? B. So what are the uses of Hare's apparatus? Now let's first go back and look at this Hare's apparatus. It is used to compare the densities of two different what? Liquids. So we use Hare's apparatus to compare the densities of two different liquids. Number two, we can also use Hare's apparatus to measure the relative density of a liquid. You see, based on pressure exerted by a liquid column. So there are two uses of Hare's apparatus here. One, we can use it to compare two different liquids. We can also use it to measure the relative density of a liquid. Now that one can only work if one of the liquids is water. We can get the relative density. So as I told you, this is how Hare's apparatus looks like. Now how does it work? Here you have a different liquid, we are calling it liquid A. And here you also have a different liquid, we are calling it liquid what? B. Because the liquids are different, it means their densities are also different. You can see this is liquid B. It has a different density. You can call it density 1. And this one is a liquid B. This one was what? Liquid B. Sorry. Then this is liquid A. Now liquid A is different from liquid B. Therefore, it has also its own density. So this is density 2 because this is a different liquid A. This one is density 1 because the liquid is B. So liquid B of a different density 1. Liquid A of a different density 2. Now, when this tap is opened, maybe let's look at the explanation. Air is sucked out of the tubes through the center limb of the T-piece and the clip closed. Now, this is what I was trying to say. Here, inside here, when you close this tap, there is always air inside here. Now, when you are going to compare the densities of these two different liquids, the first thing is you need to remove this air. Now, how do you remove the air? You can use what we call a vacuum pump. You see, you open here, connect the vacuum pump. The work of the vacuum pump can help us to remove the air which is inside. So after removing the air which is inside, then you close the tap. So you first remove. That's why this statement is saying air is sucked out of the tubes. Which are the tubes? This is a tube, this is a tube. This one is a tube, this is a tube. So there are two tubes there. So you suck the air which is inside here. You remove it by using what? A vacuum pump. Now when you are sucking, you first open the tap. You connect to the vacuum pump, remove the air inside, and then once the air has been sucked out, you close the tap. Now, you realize that this tap here also looks like a T. You see? Like this. It looks like a T. So that's why we are saying you can do that using the center limb. This is the center. And the center of this side and this side. So when you are sucking the air, you use this center limb. You open the tap, put the vacuum pump, remove the air, then you close using the center limb, which looks like a T. Then after that, removal of air causes a reduction of pressure inside, resulting to atmospheric pressure, pushing the liquids up the tubes. So we are saying once you remove this air inside, what happens? It means the pressure inside will be low. Why is the pressure inside low? Because the air which was causing pressure inside is the one you have removed. So once you remove the air, the pressure now inside reduces. And when it reduces, atmospheric pressure, you see this tube. These tubes are inside a container which has a liquid. But this container, the liquid is exposed. The top side of the container is not closed. So it is open to atmospheric pressure. So the atmospheric pressure will be pressing this liquid downwards and also pressing this one downwards. So as it presses with some force or pressure, the liquid will now pass through the tube and rise. As it presses, the liquid passes, it is forced down, and because this part is open, it will now go like this. So at the end of the day, once air is removed here, it means the outside pressure will be greater than the inside what? Pressure. So atmospheric pressure will press the liquid down, and then the liquid will rise through the tubes. Now the same atmospheric pressure, but the way the liquids will rise in the tubes will be different. You'll realize that one liquid will rise more than the other. As the diagram shows, liquid A rises more than liquid what? B. So this one we can call it height 1, and this is height 2. The height is measured from the top of the liquid in the container up to where the liquid stops. So that is the height. So this will be height 2 because this is of density 2. This is a liquid of density 2. So this one we can also call it height 1 because it has density 1. So you could use this information to compare the densities. How do you compare the densities? You will say the pressure of this liquid must be equal to the pressure of this liquid. So the pressure of liquid B, A, is equal to the pressure of liquid B. Now, since they are both liquids, we are going to say, remember how do we get pressure in liquids? You get height times density times acceleration due to gravity. So this one also height times density times acceleration due to gravity. Why are we using the same formula? Because these are both liquids. This is a liquid, this is also a liquid. Much as they are different. A different liquid and a different, but they are both liquids. So pressure in any liquid, you use the formula height times density times acceleration due to gravity. Now, since there are two liquids, one of them we shall call them 1, then the other one 2. Liquid 1, which one is the liquid 1? Liquid 1, the one which has 1, density 1, height 1 is liquid B. Then the one which has The one which has density 2 and height 2, that one is liquid what? A. So the pressure of liquid A is the same as the pressure due to liquid B. Using this formula, you can calculate anything about these two liquids. So let us see an example. Let's see an example of a question. For example, if the density 2, find the density 2 rather. Find the density 2 if density 1 is given. You know, when they want you to find the density 2, it means all the other things you have been given. H1 is there, you see, H1 is 10 centimeters. Density 1 is also given, you see, 13.6 grams per centimeters cube. So you must have been given, if they want one of them, like here they are saying find the density 2. It means all the other things have been given. So if all other things have been given, you see, density 1 is given, height 1 is given, height 2 is given, you see. So you simply say, since the examiner wants you to find density 2, you say, use the formula here, that H1 times density 1 times G is equal to H2 times density 2 times G. Why are we not saying G1 and G2? Because G is the same for both liquids. For liquid 1 and liquid 2, the acceleration due to gravity is the same, does not change. But H1 and density 1, H2 and density 2 are different. Why are we saying so? Why are we saying so? Because this liquid is different from this one. So because they are different, this one has a different density 2, this one has a different density 1. You can see even their heights are different. This height is smaller, this height is bigger. So what does that mean? It means the heights can change, you see. The heights can change from H1 to H2. The densities can change from density 1 to density 2, but acceleration due to gravity remains what? The same. So using our formula there, since the examiner wants us to find density 2, we shall say H1, which was it? H1 is what? 10 times density 1. Density 1 is what? 13.6 times acceleration due to gravity they have not given us. So we use 10 times 10 equals to H2, where we given H2, yes, 170 centimeters, times density 2, which we are looking for. So we leave it as density 2 times 10. So when we multiply this side, we get 1,700 times density 2. When we multiply also this side, we get 13,600. So we divide both sides, and our density 2 is going to be 0.8 grams per centimeters cubed. I want to remind you that the units for densities must be the same, and the units for heights must be the same. You see, H1 is in centimeters, H2 is also in centimeters. So what does that mean? Density 1 and density 2 must also have the same units. Since density 1 is in grams per centimeters cubed, density 2 can also be in grams per centimeters cubed. Let's look at another example. This one says, an open U tube contains columns of water and kerosene over mercury as shown in the diagram below. So this diagram looks like a U. You see, this is how you write U. So it is a U tube, and it contains how many liquids? 3. There is a kerosene, that is a paraffin. There is a water, and then there is mercury. You see? So they are saying an open U tube contains columns of water and kerosene over mercury. So the water and the kerosene are over mercury. You see? This is the water on top of mercury. This is the kerosene on top of what? Mercury. So which liquid do you think was powered first? It was mercury. They first powered mercury, then later on they poured this side water, this side kerosene. What is the purpose of having mercury here? Because without this mercury, this water will mix with what? Kerosene. And we know that water and kerosene are miscible liquids. Remember that chemistry? Liquids which can mix. So when kerosene mixes with the water, you will not know which one is water and which one is the kerosene. So for that reason, to separate them, you first pour mercury. Because the two sides of the tubes are open, the mercury will balance. You see, atmospheric pressure will make this mercury to balance. Then you pour water, then you pour kerosene. Now you can see the height of water is smaller, 8 centimeters. Then the height of kerosene is 10 centimeters. Now using that information, they want us to find the density of kerosene. And in bracket, they have given us the density of water as 1 gram per centimeters cubed. So what do we do in this case? Solution, we shall simply say the pressure of water and the pressure of kerosene are equal. You see, the tube is open, this is open, this side is open. They are both open to atmospheric pressure. So the pressure exerted by water is equal to the pressure exerted by kerosene. We shall not mention mercury. Why? Because the work of the mercury is just helping us to separate these two. So that is the work of mercury. But basically, we are going to deal with the kerosene and water. So, pressure of kerosene is equal to pressure of water. Kerosene, which is a paraffin, and water are both liquids. So the formula for getting pressure is the same. So we shall say height times density times acceleration due to gravity is equal to height times density times acceleration due to gravity. Now, to make them look different, we shall put a K down here, meaning that this is the height for kerosene, this is the density for kerosene. This side is the height for water and the density for water. As you can see, the acceleration due to gravity, you don't write K or WY because it is the same, does not change. The liquid can change in height, it can change in density, but the acceleration due to gravities are the same. So we are now going to substitute. The height for kerosene, what was the height for kerosene? It was 10 centimeters. Then for water, it is 8 centimeters, you see? So we shall write here 10 centimeters as the height for kerosene. Then the height for water will be 8. Then the density of kerosene, we shall leave it like this because it is the one we want. You see, the question says, find the density of kerosene. So it is this one we are looking for. So it remains. Then times acceleration due to gravity. Since we were not given, we use 10. Okay? Then here, the density of water is also given. 1 gram per centimeter cubed. So we leave it as 1. Density of water is here, it is 1. Times acceleration due to gravity, which is what? 10. Now, when you multiply all this, you get 80. When you multiply all this, you get 100 density of kerosene. Because we are interested in density of kerosene, what do? We divide both sides by 100, 100. So this one cancels with this. And we remain here with the density of what? Kerosene, like this. Then when you divide these two, you get 0.8. Now, my question is, what is going to be the unit for density of kerosene? You see? Let's go back to the diagram. If the heights are the same, centimeters, centimeters, you can decide to change them to meters or just leave them in centimeters. After all, this one is in centimeters, this one is in centimeters. So what does that mean? The density of water was given in grams per centimeters cube. So what does that mean? If the height for kerosene, they are the same, they are in centimeters, and then the density of water is given in grams per centimeters cube, it means the density of kerosene should also be in grams per centimeters cube. So our answer here will be in grams per centimeters cubed. Supposing there were 4 marks here, we would give 1 for the formula, 1 for substitution, 1 for the correct answer, which is 0.8, and then for the correct what? Unit, grams per centimeters cubed. But another student would change these grams per centimeters cubed. You know, density has 2 units. There is a grams per centimeters cubed, there is a kilograms per meters cubed. So If you want to change this one to kilograms per meter cubed, you multiply this value by 1000 and you get 800. Then the units will change from grams to kilograms, centimeters cubed to meters cubed. So you will be correct if your answer is this. You will also be correct if your answer is this. Now, you would also be correct if you handled this thing by using SI units. You change the height into meters. How do you change the height into meters? You divide by 100. This one also divide by 100. The centimeters into meters. But I think that would be a longer process. This is enough. Just substitute. As long as this is centimeters, the heights are in centimeters, they cancel. The densities are both in grams per centimeter cubed, they cancel, and you get your answer. So this one works very, very well.